I'm Morgan, and we're going to go over the first lab together and do our video. So I kind of already worked all this out, but for our first table, to go from millimeters to meters, or centimeters, I guess, is what I did first, and then I changed it to millimeters and then went to meters. So I just times 10 to get to millimeters, and then I take centimeters and divide by 100 to move the decimal over to get meters. The second table, we were given Fahrenheit. So to get Fahrenheit to go to Celsius, I just took my Fahrenheit, so my 116 minus 32, times that number by 5, and then divided by 9. And then I did that all for the Fahrenheits, and that got me my Celsius. And then to get Kelvin, I took the Celsius, added 273.15, and that's how I got the Kelvin. And I actually did it all on this sheet that I'm just following along. So the third table, I was given the actual mass. I just guessed. There was a scale that I had that I could use to actually weigh them, but I just took a guess on that. So that's how I got those numbers. But I was given these, and then to get from grams to kilograms, you divide by 1,000. So I just take 7.6 and move the decimal over 3 places, 1, 2, 3, and I end up with 0.0067 or 76. Sorry. To get my kilograms, and then I did that for the whole table. Table 4, I was given mass A and B, A and B, and I think I was also given the volume of 5, and then to get the liquid grams up here, you can see we just subtract those two, so that's how I got those two numbers. And then to get the density is mass over volume, so I just took my mass, which was here, and my volume, which was here, and divided those numbers, and that's how I got that. And then my percent error, here's the equation I used. My percent error is my measured value minus my accepted value all over my accepted value. And then I was given my accepted value as for water and then alcohol. So water was 1 gram per milliliter, and isopropyl alcohol was 0.786 grams per milliliter. So I just took my actual number, my measured value of density, subtracted those given values, and then divided by the given or accepted values, and that's how I got my percent errors. I guess we can go through this whole thing. This just said 3 examples, but okay, and then table 5, to get my volume, is just centimeters cubed, so you just times length times width times height, and that's how I got my volume. And then to get density, again, its density is mass over volume, so you just do your mass, which is right here, so your 4.3 over your volume, which is 0.625, and that's how I got my density. Table 6, there we go. To get my final volume, I think I was given this one and this one and this one. So to get my volume over here, it's just the difference between your initial and your final, so you subtract those two. There's that. Subtract those two. 8 and 7 is 1. That's my volume. And then again with the density, it's grams over milliliters, or mass over volume. Mass over volume. You divide those, and that's how I get those two numbers. And, oops, that's out of order. Okay, Again, this is density. It's still the same. So mass over volume. Mass over volume of displaced water. And that's how I got my density. Molarity. We can do molarity. Let me look over here. Okay, so table 8. So to get our molecular weight, which is right here, we take our molecule, and we know we were given that carbon is that, hydrogen, and we have 12 of those, so we're going to times that by 12, and then we're going to add hydrogen is 1.008 grams, and then we got these numbers from the periodic table, but we have 22 of those atoms, so we're going to do that. Plus we have oxygen, which is 15 grams, and we have 11 of them. So that's how we got our 331. And then to get our, I think we were given, oh, maybe not. Okay, and then to get moles, so now we have our molecular weight, so to get moles, you do your mass, which is 8, over the molecular weight, which was 331. And that's how we got our 0.024. And then to do molarity, we do our moles over our liters. And that gives us our molarity. And then we could take this number, and it's actually all of our initial concentration. So that's how I did this last table for, we use this equation down here. Our mass times our volume initially times our end mass times our end volume. Whoops, that should be a 2. So I use this equation to get our final concentrations with the numbers given. And that is it for Lab 1.